Yesterday we talked about springs. I know we talked about this just a little bit. And anywhere where we have an aquiclude coming to the surface, we get springs, a natural spring. So I want you to think about this. Let's say that I've got a clay layer right here, and I've got my water table. So it gets my zone of saturation. And normally, if I'm on a slope, that would just keep going, right? Well, the problem is the aquiclude prevents that from going down. So what's going to happen at the aquiclude is we start getting natural springs that start to flow from the groundwater seeping out. And that's how we get natural springs. So this picture up here is a perfect example of that, where you have groundwater that is basically flowing out of the rock. So that's an example of natural spring. Again, this is all part of karst topography. And if it wasn't for the limestone, we really would not have any of these features, which is why we don't really have a lot of them in our area of the state. And then yesterday we talked about an artesian well. And so we go, is that kind of like a geyser? Yes and no. How many guys have a teapot on your stove?
Oh, I do.
Okay. You ever used it?
I don't.
I do, and I use it sometimes to make my
I used it to make my oatmeal in the morning. All right, now. I know what he said. I just told what I do.
I don't understand
Okay.
how hot water can instantly turn on and it'll just like.
I try to figure out what I was doing. All right, now, talk about how the teapot actually works. Why does it get, all right, why does it get steamy?
Because the water's heating up.
All right, so what if you filled that pot all the way up?
Then the water would go.
Water wouldn't have anywhere to go. So you actually need to have air in there in order to create the steam. You need to have a cavity in which the water vapor can rise into. Okay? So you usually want to fill like about halfway, and that'll actually give you a really good temperature for the water. So as the water's getting hot, it becomes water vapor, and then that gas collects inside the teapot, and then eventually you get this really loud whistling sound. Why is that? Well, why does it scream like that?
It's
There is a very narrow hole. Okay, it's like screaming through a whistle. The whistle holds a very, very small hole. And what it's going to do, we're going to see that here in this diagram, where the water is getting heated up. And notice right here, notice our little gap. Notice how it's constricted. So we're heating up. The air can't get released, and so we get gases that build up inside the tube, and then we eventually get a sudden release of that energy, and we now have the geyser. And that's basically the same way a teapot works. You build up that pressure inside the pot, and then the steam comes rushing out that tiny tube, and that's the whistle sound we get. It's basically the same thing as a geyser. It works the same way. And then this again, referring back to what we talked about yesterday with artesian wells. You have two aquicludes, and then you have the water zone of saturation in the middle. And what's happening is this water is under pressure, right? Because you got more layers pushing down on it, and it can't go down any further, so it's squeezed under pressure. All right, if you've ever had a balloon, and why is when you poke the balloon with the pen? Why does it pop?
Because you release that air.
No.
pressure.
Yeah, it's something air.
Okay, let me ask you this. Take the same balloon and have it somewhat inflated and then poke it. What happens? It doesn't pop. It goes, I don't know how it goes, right? But why does it pop when it's full of air?
Helium.
Not the helium. It is all about the pressure. that sudden release of that much pressure, all that pressure is trying to immediately be released. One of the things we talked about, remember we talked about the essential understandings of science. This is one of the common things. Everything is trying to go from highs to lows. The high pressure in the balloon is trying to equal the low pressure outside the balloon, so the air quickly rushes out. When it does that, it literally blows out the balloon. With an artesian well, it's very similar. You have the water, the zone of saturation, completely squeezed under a whole bunch of pressure. And all you have to do is drill and poke that surface. As soon as you break that surface, what happens to all that water? It starts rushing out. And that is how you get a natural well of water, and there's no need for a pump. It will automatically, due to the forces within the earth, it will automatically pump that water into your house. So that's kind of a neat thing. That's the advantage of having an artesian well. Unfortunately, there's not a lot of places that have that, but that's basically how they work. All right, I'm pretty sure that's it for us. Yeah. Yeah.